take notes with your paper. Okay, you can begin. Alright, so we're learning about contour and topographic maps. Topographic maps are a type of contour map. They're not exactly the same thing. Contour maps can be used not only for topographic maps. Topographic maps are going to look down on landforms. Okay? So, why do we use topographic maps? Contour maps? Because they show objects, three-dimensional objects in a two-dimensional way. The lines that you see on the maps, so for example, this is a contour map of a landform. The lines that you see represent change in elevation. Can someone tell me what elevation is? Drew?
Height.
Height. So if I have a positive elevation, give me an example of something that would have a positive elevation. Connor?
Mount Everest.
Mount Everest would have a positive elevation. It would have a huge elevation. Yep.
Mountain.
Mountain. Any mountain is going to have a positive elevation. Let's also think about things that will have negative elevations or depressions. What would be an example? Josh?
A Lego guy.
A Lego guy. Lego guy actually stands up. So that would be a positive elevation. Bailey?
A pencil.
Pencils stand up. What would have a negative elevation? So if the line was here, what is something that would go down? So I'd have to draw that negative elevation. Gabby? Ashlyn?
Water.
Does water or where water is? Where water is. Does anyone, raise your hand if you've been on Google Earth? Ever. If you go over the ocean, it's going to show you landforms that are in the water. Okay, a lot of you have probably seen that. Shows the Mid-Atlantic Ridge down the middle. Shows the huge depression. That's an example, or Lake Michigan, of where the contour lines would make a depression. Okay, so there's impressions which go up, depressions which go down. Two concepts that I want you to think about. Drew?
Valleys.
Valleys, it depends on where sea level is. Because 0 is technically sea level. So if the valley, like that valley is below sea level, then it would show up as a depression on a map. Whereas if you were in the middle of the mountains, which are higher than sea level, the valley doesn't necessarily go to 0. So it would still be an impression, it would still be going up. Yes? Dirt would be, generally speaking, an impression. A ditch, depending on where sea level is, a ditch could be less than 0. Alright, very good. The next thing that we're going to talk about are the lines themselves. When you see these maps, and you'll be seeing 8 of them later today, when you see these maps, the closer the lines are, the greater the changes. So we're going to talk about scale later today, and how that relates to the real world. But these lines, can someone come up here and show an example of where they think it would be a greater elevation change, so faster elevation change? Jake, just go up and point to the map. So those are closer than, let's say, something like, yeah. Go back. I don't know if it's got. Okay, we're good. Nope. Hit the left button. Okay, so a great example. So somewhere right here would be a fast elevation change, or somewhere right here would be faster, whereas this would be much slower. This is an example of this. So this is the landform. It's made out of clay. This area is going to be this side. As you can see, it's slightly less steep, whereas this is going to be right here where you can see it's almost straight up and down. Does that make sense? Any questions so far? Okay. How do we read? Oh, do you have a question?
So it would be like a map, like you would see it from the sky, not
It's going to be a bird's eye view, correct. You're not going to look at it from the side. You're going to be looking at it from the top. And if you get really good at reading contour maps, you're actually able to see the 3 dimensions taking place on a 2-dimensional surface. So like I personally could look at this and know what it looks like and where the steep areas are, where the ridges are. Right now, I don't expect you to be able to read it as easily, because I've seen these a lot. Any other questions? Okay. So how do we read it? The contour lines are the big, important part of it. They represent the edges of something. So, in the middle of something that has a positive elevation change in impression, there is going to be a peak. At the bottom, there's going to be a valley. At the edge, where it flattens out, there are going to be no lines because there's no elevation change. So someone give me an example of a peak. Connor.
Top of Mount Everest.
The top of Mount Everest. Someone give me an advantage or an example of something that could was a valley. Drew.
Death Valley.
Death Valley. Okay, the lowest point of Death Valley is negative. Example of maybe something that's called the edge of a landform.
Grass.
Okay, so grassland, a field, flat field, farmer's field. Okay, does that make sense? The big thing is on their maps. Be honest. If you didn't, you didn't. That's fine. If we are looking to read the map properly, we need to have a key. We need to know what certain things are, whether that be what the slide looks like, different colors you used. In this case, it's going to tell you the elevation change. So sometimes the lines are going to represent 5 feet of change. So from there to here. Sometimes they're going to represent 100 feet of change. Can someone give me an example of where they would think that the rate of change would be 100 feet or more? Zach? That's only about 100 feet tall total, so it'd just be one line then. Connor?
Like, I feel weird to keep saying this, but Mount Everest.
Mount Everest, something that's 29,000 feet tall, you're going to want it to be larger intervals. You're not going to want it to be every 5 feet, otherwise you'll never get to the top. So that's where you have to look at the key to see the different levels of variation. What do the lines mean? I'm going to go over quickly a couple of the colors and what they represent because you'll be seeing them later today. Number 1, red lines are going to mean depression. So which way does that go? So starting at 0, it would be a negative. Green, black, or brown lines are going to be positive, which means, let's say it as a class. Okay, positive elevation equals up. Positive elevation. Negative elevation. Okay? And the last thing I really want you to remember about the lines are that they're generally going to be in 5-foot or 100-foot intervals, generally speaking. Every once in a while you get something different. With things that we do at school, if you're to do the playground, you probably want to do 1 foot, because the playground is only 8 feet tall. Okay? Any questions thus far? Alright, the key things that you need to take from this, and this is online already, and the lesson will be as well. You must respect the scale. So if the scale of the model is going to be, or the scale of whatever it is, Everest is 29,000 feet tall, you're not going to want it to be going by foot. Okay, that means you'd have 29,000 different lines. You need to respect the legend. A contour map is a 2-dimensional drawing that represents something that's 3-dimensional. You need to understand what elevation is. So if it's a positive elevation, it would go. If it's a negative elevation, it goes. Good. And scale we're going to talk about later, but that's the ratio of the distance between something that's real on Earth and something that you are creating. So if you were to create a small model of something that's very large, you would want to use a scale, so 1 inch equals 100 feet, or 1 inch equals a mile. Yes?
Oh, when I do remember the negative and positive, for positive, you have a backspace, which is up, and then
Okay.
negative is negative.
So point down. It's a great way to remember it. Did everybody hear that? Positive elevation would be smile. Negative elevation would be frown. I like that one. Alright, any questions? Alright, you can stop there.